My name's Adam Atkinson. This is my 5th gathering. Thank you for having me back again. What I mostly do in connection with this kind of thing is help the University of Pisa commit fraud for about 1 week a year. This year it was about a month ago. I do a games and puzzles stand at the prospective students open week. This has nothing to do with anything they would possibly do if they go to the University of Pisa, but by the time they find this out, they've already handed over their money, so it's too late. I take 20 donkey puzzles with me, which is this magnificent beast here, along with a lot of other things. If you've never tried the donkey puzzle, do come and experience it later. This has nothing to do with brontosauruses. Do people here like brontosauruses? I just want to reassure you that I'm not hunting them in the sense of killing and eating them. I'm just, looking for them, so it's all sustainable. Indeed, mighty Brontosaurus, I think, is more the attitude we should be taking here. Now, someone's already mentioned this. You get occasional people asking you things like, when the hell do you ever do any of this kind of stuff in real life? Or possibly, what's the hardest mathematics you've ever used in real life? Fortunately for me, my answer to both of these questions is the same story, so I can do both of them together. And I realised between the previous gathering and this one that it might make a reasonable story to use here. Something that's a bit G4, G11-y. In normal circumstances, I can tell people how to find me by saying I'll be the one wearing the purple bow tie, but that's not good enough here. But at first, something that doesn't have anything to do with anything either. Stoke Tourist Information Board produced this leaflet about things to do in Stoke, and the section on shopping contained the startlingly frank admission, you cannot fail to go home without a bargain. If I were Stoke Tourist Information Board, I would keep quiet about this, but that's just me. Also, something that I didn't think was worth a whole talk, negative prices in supermarkets. I've got a couple of receipts here with me today where I've been charged negative amounts of money for a couple of items in my local supermarket. Maybe this is something you've all seen before. In case it isn't, come and have a look, and I've got a short present thing about how it happens. Right, so my real life story, I work for a data communications company which also does telephony. In particular, we run telephone systems for large organisations, so imagine the Department of Defence or the Metropolitan Police or IBM or something, and there are telephone calls between people inside the building which are free. Incoming calls are somebody else's problem, but calls leaving the building you have to pay for. And several years ago, somebody very senior to me at the company came to me and said, one of our customers feels that we're ripping them off. I said, and you're telling me this because, well, we're not actually sure if we are or not. Oh, and you want me to do what about this? Well, could you come up with some kind of mathematical excuse for why we're not? Well, I said that would rather depend. I would need to actually have some kind of, idea of what we're talking about here. And so they said, the way it works is this. As soon as the telephone call is connected, you pay a certain amount of money, and if it lasts up to some amount of time, that's all you pay. But if it goes over that amount of time, there's some extra charge per minute from that point onwards. So let's say it's A for the first B minutes and then C a minute after that. So your price time graph looks like that with time across the bottom and price up the side. Something which didn't occur to me at the time but did after that, perverse incentives. If the diagonal bit is steep enough, you'd actually be better off hanging up the phone every B minutes and dialing again. So let's assume that doesn't happen, but maybe it does, although the conversation, thank you for speaking to me, Secretary of State. You'll understand that I'm going to be hanging up on you every 6 minutes and 40 seconds for the duration of this conversation. Yeah, maybe not. How could we compare tariffs in general? Clearly, if my company is the black line here and the competition is the green line here, then the customer has a point and we're in trouble. There are some less easy cases. One would be this, where it, they cross over, or possibly it crosses over and then crosses over again. And on the face of it, you really can't say anything terribly useful in either of these two cases without knowing some extra information along the lines of, well, how long are your telephone calls? There's some point B where every call gets charged A immediately, and then anything beyond the line B gets charged an extra C pence a minute. So we need to know stuff about the probability distribution of the lengths of telephone calls in order to be able to talk about this. Now, I happened to know what it's commonly supposed to be, which is the maths part of this talk, but there's also the is this really true element, which is the reality part of the talk. Do people know what the probability distribution of the length of telephone calls is commonly supposed to be by people who model these kinds of things? Comparing different tariffs doing this would be a right pain because you're going to have different values of B and you need to look at the average excess lengths of telephone calls beyond each of those, and it's all very annoying. What would the nicest possibility be? Well, of course, there's a probability distribution, the exponential distribution, where it doesn't matter because it's always the same shape beyond any given point. And what we have here is a histogram from 300,000 actual phone calls made by one of my customers of how long they were in seconds. Now, a lot of people would expect, and this is the Brontosaurus part of it, that the probability distribution would be Brontosaurus-shaped. I here refer to a result by Anne Elk in the 1970s. The Brontosaurus is thin at one end, much, much thicker in the middle, and then thin again at the far end. However, my Brontosaurus hunt has failed because, based on actual telephone calls, it's, not ridiculously silly to say that it's an exponential distribution. You might notice the astonishing peak of 0-length telephone calls. That's because I haven't actually cleaned up some of this, and if you want to know what should have been cleaned up and hasn't been, come and talk to me afterwards. But plausibility-wise, I'm willing to hand-wave for the sake of flim-flamming customers that an exponential distribution isn't totally silly as the way to model telephone call lengths. Thank you very much.